Hello, this is question 6 on your June 2022 paper 3 from OCR, the A-level paper. And you have a diagram which shows this curve, the square root, which is this one, and then this exponential, which is this one, which intersect on the y-axis, so here, and the shaded region is bounded by the two curves and the x-axis. And we have to find the area, giving your answer in this form. So remember to check how you have to give your answer. P and Q are constant to be determined. So we have one function and another function. What we are going to do is to find two different areas. So the area under this curve between this point, and the area under the other curve. So this is like area 1, if you want. And then we are going to find the area under this curve, integrating this function between this point and this point. Yeah, and this is going to be area 2, and then we can add them together. For that, we need to find this point and this point. Yeah, so I want to integrate between this point and 0. This point is from this curve when y is 0. So that's the first thing I'm going to do. I'm going to find the point of intersection with the x-axis. So when y is 0, I have root 2x plus 9 equal to 0, which means 2x plus 9 is 0, which means x is going to be minus 9 halves, or minus 4.9. Yeah, so this is minus 4.5. I say 4.9, sorry, 4.5 or 9 halves. So I'm going to do the first integral. I'm going to find a1. a1 is going to be the integral between minus 4.5 and 0 of that square root. We could use substitution. Yeah, so call this u and use substitution, and it's quite straightforward, but you don't even need to do that. When you have ax plus b as the derivative is just a constant, we can integrate that very quickly. So I'm going to integrate, and I'm going to write it as 2x plus 9 to the power of 1/2, because it's going to help us. I have a function to the power of 1/2, and the derivative of the function is going to be a constant, so it's very easy to adjust. So it's going to be this to the power of 1 more. So I have 2x plus 9 to the power of 1 more, so 3/2, divided by the new exponent, which is 3/2. So I'm going to write the 3 here and the 2 at the top. And then divided by the derivative of this function, which is 2. So I'm going to write here times 2, and then we can cancel this. This is going to be between minus 4.5 and 0. So I'm doing 2x plus 9 to the power of 3/2 divided by 3, between minus 4.5 and 0. When I substitute the 0, I have 0 plus 9, 9, so 9 to the power of 3/2 divided by 3. And when I substitute the minus 4.5, I have minus 4.5 times 2 is minus 9. Minus 9 plus 9 is 0. I could then skip these steps, because if your answer is wrong for whatever reason, you at least would get the marks for the working notes, because it's clear what you're doing. Yeah, 9 to the power of 3/2 divided by 3 is 9. So that's area 1. Now we are going to find area 2. And to find area 2, I'm going to find this value here. That is for this function when y is 0. So I'm going to make y 0 again. So I'm doing for the other part. Y 0 is 4e to the power of minus 2x minus 1 equal to 0. That was the function, no? Yeah. This means e to the power of minus 2x is going to be 1/4. Taking logs, ln minus 2x is going to be ln 1/4, which means x is going to be ln 1/4 divided by minus 2. We can simplify this a bit easily, because if you do with the calculator, it's going to give you the decimals, but there is a nicer way of writing it. So ln 1/4 divided by minus 2, I'm going to do here. So ln 1/4 divided by minus 2. Ln 1/4 is the same than ln of 4 to the power of minus 1. Yeah, I can bring my 4 to the numerator with negative exponent, divided by minus 2, which is minus ln 4. Yeah, I can take the exponent to the front. 4 is 2 squared. Yeah, so I'm going to write 2 squared here, and you're going to see it very quickly. So 2 squared. I can take the 2 at the front. These 2 can go at the front just using the properties of the log. So I have minus 2 ln 2 divided by minus 2, and this is ln 2, yeah, which is much simpler to have this expression. So this point is ln 2. So now to find area 2, we are going to do the integral of between 0 and ln 2 of my function, which is 4e to the power minus 2x minus 1. Is that one, no? Yeah. Remember, when we differentiate e to the power of kx, we have the k, e to the power of kx. Nothing happens with the exponent, yeah? So when we integrate, we are going to divide only by this, the derivative of the exponent, yeah? We are going to divide by the k. So if I integrate that function, I'm going to have the 4 at the front, and then e to the power minus 2x, the integral is going to be e to the power minus 2x divided by minus 2, yeah? Then the integral of 1 is x, and I'm going to substitute between 0 and ln 2. This is going to be equal to, I'm just going to divide the coefficients before substituting. Yeah, just one step more, and then I substitute. I have minus 2 e to the power minus 2 ln 2, and then we are going to see what that is. Ln 2, and then minus ln 2. So I have substitute ln 2 in both sides, and then minus, I substitute the 0. When I substitute the 0 here, I have e to the power of 0 is 1, so it's going to be minus 2, and the other bit is going to be 0. This thing here, yeah, if you do with the calculator, you are going to get the decimals, and you don't want that. So we are going to work with this. Remember, when you have e to the power of ln a, it's just a. Yeah, so we want to write this expression as e to the power of ln. So this minus 2 can go as an exponent, and then we will have it, yeah? So e to the power minus 2 ln 2 is e to the power of ln 2 to the power minus 2, which means this is going to be 2 to the power minus 2, yeah? And this is going to be 1/4. So all this thing is 1/4. If we go back to our expression, we have minus 2 times 1/4 minus ln 2 plus 2. So I have 2 minus 1/2. 2 minus 1/2 is 3/2, no? 3/2 minus ln 2. And this is area 2. So the total area is going to be area 1 plus area 2. Area 1 was 9. Area 2 is 3/2 minus ln 2. And I have 18 plus 21/2 minus ln 2. That's my total area. And they were asking me about the coefficient. So p is the number that is alone, and q is the coefficient of ln 2. So I'm going to just write a line saying that p is 21/2 and q is minus 1. Yeah, and that's all with this question.